Hey Valley Middle, here to review for the MCA, starting with the Unit 1, whole numbers. I can determine odd and even numbers. Well, anything that ends in a 1, a 3, a 5, a 7, or a 9 is an odd number. If it ends in a 0, a 2, a 4, a 6, or an 8, it is an even number. So 25, this guy is odd, just like a couple of my friends. 74, well, it ends in a 4, so that's an even number. Prime or composite? Is 24 a prime or composite number? 24 has more than two factors. It can be 1 and 24. It can also be 2 and 12. So this guy is a composite number. 17, on the other hand, 17 is prime. It just has two factors, 1 and 17. So that's a prime. And this is a composite number. I can write products as I can write powers as products of factors. So 3 to the 4th, this simply means 3 times 3 times 3 times 3. This is the base. The exponent tells you how many of them there will be. So base and exponent, a base of 3, and there's 4 of them. I can write powers in exponential form. Well, again, this is the base, there's 4 of them, and our exponent is going to be 1, 2, 3, so this is 4 to the 3rd. Scroll down here. I can evaluate each expression. Well, this is 2 times 2 times 2 times 2 times 2 times 2. There's 6 of them. So I can do this without a calculator. 2 times 2 times 2, well, these 3 here together equal 8. And these 3 here together will equal 8. So I have 8 times 8, which is 64. Or you can just do on your calculator 2 times 2, which is 4, times 2 is 8, times 2 is 16, 32, 64. Okay? I can determine the factors of the following whole numbers. So 48, make a little factor tree here. We can go in there 1 and 48. We can go in there 2 times. 2 goes in there 24 times. 3 fits into it. 4 plus 8 is 12, so 3 goes into 12, so 3 will go into 48. It'll go in there 16 times. 4 goes in there 12 times. 5 doesn't go in there. 6 goes in there 8 times. So those are all of your factors right there. 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. These are the factor pairs. Each of these numbers here, because they go together to equal 48. Okay. Otherwise, they're all just called factors unless they're with their partner. I can express the whole number as a prime, as a product of prime factors with exponents. So 32, this is basically, we're doing prime factorization here. So I can break 32 down into 2 times 16. And I can break that. I'm going to move this up so you can see it. I can break 2 times 16 down into 2 times 8. There's my 16 again. And I can break that down into 2 times 2. Break 8 down into times 4 times 2. Well, I can still break this 4 down. So I can break that down as 2 times 2 times 2 times 2 times 2. So I just keep carrying my numbers down, and I just break down one at a time. So this is 2 to the 1, 2, 3, 4, 5. So 2 to the 5th. And that makes sense because up here, 2 to the 6th was 64. So if I stop short at 5, 2 to the 5th will be 32. Let me take a look at that work there. Sorry, I forgot to slide that down. Okay, keep going down here. Get the rest of the page out. All right, I can find the greatest common factor of 2 or more numbers. This is actually 3 here, so the greatest shall be the least is the little thing I always say. The greatest shall be the least. So I start off with the smallest number, which is 16, and I factor that number out. 1 and 16, 2 and 8, 3 doesn't go in there, 4 goes in there 4 times. Now I start with the smallest number because there's no way that big factors of 36, like 36 itself, is going to fit into 16. So The largest possible common factor of 16, 24, and 36 is 16. So then I just start asking questions. I ask from the bottom up because we're looking for the greatest. Does 16 go into 24? It doesn't, so it can't be 16. Does 8 go into 24? Yes, 8 goes into 24. Does 8 go into 36? No, it doesn't go in there. Let's try 4. Does 4 go into 24? Yes, it goes into there. Does 4 go into 36? Yes, it goes into 36 as well. So 4 is a factor of 16, 24, and 36, and it is the greatest common or the greatest shared factor. Determine the multiples of the following numbers. So the multiples of 5, this is basically skip counting. So you can just go 5, 10, 15, 20, 25. So this is the first multiple, second multiple, third multiple, fourth multiple, fifth multiple. So multiples mean skip counting. Remember that? All right, I can find the least common multiple. The least common multiple. Well, I say the LCM, I always say the least shall be the greatest. It's just the opposite. So I start off with 28. And I skip count by 28. 28, 56, and you can do that in your calculator like this. 28 plus 28 plus 28, 84, plus 28. I got 112. I usually do 4 multiples. Then I just start asking, does 14 go into 28? It does. You're done right there. The least common multiple of both of these numbers is 28 itself. Okay? All right. Moving on. Next page. I can read, write, and graph integers. Which set of positive integers is graphed on the line? So let's put some integers on the line here. So we've got -4, -3, 0, 2, 3, and 4. So the positive ones, the positive will be these ones over here, 2, 3, and 4. So my positive set is 2, 3, and 4. Whoops. Let's go with the negative ones too. Well, the negatives would be -4 and -3. And what the heck? Let's do the neutral one too. There's only one, and this is what usually confuses kids. 0 is neutral. It's not positive or negative. Absence of value, Jaime Escalante would say. All right, I can choose an integer that fits this situation, the deposit of 56. Well, if you're depositing something, you're putting something into the bank or you're adding. So this is just 56. No label, just 56, and it's positive. Okay, let's slide down here. I can compare positive rational numbers using inequality symbols. Okay, so we've got 123, and then we've got 1,232. Notice I'm not even looking at the decimals. I already noticed we've got 4 digits here, and this is in the thousands, and this is in the hundreds. So this is definitely going to be greater, this side here. So this is less than that, or remember, inequalities you can read backwards too. So 1,232 is greater than 123, or 123 is less than 1,232, and change, of course. All right, I can order from least to greatest. We've got to take a look at these guys. We've got 30,000, we've got 14,000, we've got 600,000. So least to greatest. This is from small to big. And we've got 3 numbers, so I'm just going to put 3 lines here. The smallest one here looks to be 14,000, so 14,124, that's a comma. And then the biggest one is 600,000, 600,000. 433, and the middle one would be 30,112. So there I've labeled those from least to greatest, or from smallest to largest. I can identify axes and quadrants on a coordinate plane. Draw a coordinate plane, label the x and y axes in the 4 quadrants. Well, I always think of it like a clock running backwards. This is where 1 o'clock is on the clock, and it runs backwards. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This here coming straight up, this makes the leg of the y, so this is the y-axis, and this is the x-axis. Don't axes mean y. Sorry. That's all I got. Not very funny. I can identify coordinates of a point plotted on a coordinate plane. Okay, we can do this. What are the coordinates of point C? So point C, well, we have to go either over or back, and then we're going to go up or down. In the cases of this, we only have positive things, so basically we're just going to go over first, and then we're going to go up. Because in 6th grade, we just do the positive ones. So my first coordinate, 1, 2, wait, I'm going for C, 3, 4, 5. So I go over 5 for point C. This is point C. I'm getting like Sal Khan repeating everything I say. Point C, and then I go up 1, 2, 3. So it's 5, 3 are the coordinates. This is the x coordinate, and that's the y coordinate. So point D, let's see, I'm going to go 1, 2, 3, 4. And I'm going to go 1, 2, 3, 4, 5. It's 4, 5. There we go. Let's keep it rolling. Fractions. Way down here. I can use common factors for equivalent fractions in simplest form. So here we basically have to figure out what we can do to these things to get it into simplest form. So this says 1456. I'm going to make this a little bit bigger if I can. So you can see a little bit better. Those fractions are coming out a little small. So 1456, well, I could start by dividing both of these by 7. 14 divided by 7 is 2. Have to do the same thing to the bottom. 56 divided by 7 is 8. And then I can go, well, hey, I can still divide both these by 2. So I'll divide the top by 2 and the bottom by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. There we go. That's in 1/4. Now, I could have divided by 14 right away, and could have gotten there a little quicker, but just start with some common factor and work it down, see how quickly I got to 2/8, and that's a familiar fraction I can work with. I can write each fraction as a decimal. All right, this is definitely a calculator target. So all you do is just divide it, put it into the calculator. That's so you can see it. 9 divided by 16 equals, this one here as a decimal is 0.5625. All right, I can write the following mixed numbers as a decimal. Well, we already know we're going to have 4 wholes, so we really just have to figure out what 1/3 is. So 1 divided by 3 gives me 0.333, so that's 0.3333, and I could go on forever. Or I can write this with bar notation. I can say this is 0.43 repeating. Okay, all right. I can write a fraction as a percent. All right, well, 3 divided by 5, I put that into the calculator, 3 divided by 5, I'm going to get 0.6. 0.6. 0.6 then is a decimal. To make a decimal into a fraction, you multiply it by 100, which means you move the decimal 2 times. So we've got 0.6, and then when we have to put in a placeholder there, we've got the extra little trough there when I moved it, that's 60%. I always think kids know so much about 1/4, they know that that's 0.25. And of course, to make that into a percent, you move it 2 places, you have 25%. If you can remember that, you can do any decimal or any fraction to decimal or decimal to percent. You can just remember how 1/4 and 25 works, and the rules apply the same way. Okay, I can estimate sums or differences. So we have to remember when we're working with fractions, we're going to estimate to the closest 0 fraction, the closest half, or the closest 1 whole. So when looking at this one, 12/13, we can really say that this is pretty much 1. It's closest to 1. And 3/8, well, that's really closer to a half because 4/8 would be a half. So 1 minus a half would give me an estimate of 1/2. All right, now we're generating reasonable products and quotients when fractions are involved. So when we're working with mixed numbers, we just go to the closest whole number. So the closest whole number. So I've got 4 4/5. That's really, I'm just going to call that 5. Times 3 3/4, I'm going to call that 4. 5 times 4 is 20. And again, this is a reasonable estimate for the product. All right. I can write mixed numbers as improper fractions and vice versa. Well, we just take 3, we multiply it by 8, and then we add the top. Put a little plus sign, a little multiplication sign here. 3 times 8 is 24. 24, we add the 1, that gives us 25 eighths. You want to see if you're right, you can take 25 and you can divide it by 8, because that's what that means. 25 divided by 8, it goes in there 3 times, is 24. And there's 1 left over. There's 3 and 1/8, and that's where we started. So I am correct. That is the improper fraction. And express these fractions as mixed numbers. Well, I can do the same thing. I'll just take and turn that around. 21, I'm going to divide that by 4. It goes in there 5 times. That's 20. I've got 1 left over. My mixed number would be 5 wholes and 1 part left out of 4. To see if I'm right, I can double check it. 5 times 4 is 20. Plus 1 would give me 21/4. So this is my mixed number because I just reversed the process and I got back to that original improper fraction. Okay, express your answer in simplest form. I can multiply fractions without a calculator. Multiplying fractions is pretty straightforward. I'm going to do this problem 2 ways. First of all, you can just multiply straight across. That's all you have to do. 2 times 6 is 12. 3 times 8 is 24. Well, 12, 24, we can divide both of these guys by 6. 12 divided by 6 is 2. And 24 divided by 6 is 4. Well, I can divide again. I can divide each of these by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 1/2. Right? Okay, let me rewrite this problem. 2/3 times 6/8. All of this work I did along here, you can also get rid of some of that work if you look for cross products and reduce. Like I can divide this by 3 and divide this by 3. I can divide this by 2 and I can divide this by 2. Now I can just multiply straight across. I can even take and divide this by 2 and this by 2. Now I've got 1 times 1 and I've got 1 times 2. There's my 1/2. So if you look to reduce the fractions before multiplying them or as you multiply them, boy, it's going to save you some of this time here. But if you don't know how, just multiply straight across and reduce at the end. All right, let's keep it rolling. I can multiply mixed numbers without a calculator. All right, here we go. To multiply these guys, you really have to take and make them into improper fractions. So 2 times 3 is 6 plus 1. So I've renamed this as 7/3. I'm going to multiply that times 3 times 4 is 12 plus 1 is 13/4. All right, look to my cross products. I can't really reduce anything. So go ahead and 7 times 10 is 70. 7 times 3 is 21. So this would be 91, and 3 times 4 is 12. So 91/12. So now I got to simplify that. So I got to take 91, I got to divide that by 12. Well, 12 doesn't go into 9. 12 goes into 91. Well, I know it goes into 96 8 times. So it must go in here 7 times. So 7 times 12 is 84. You can subtract here. 11 minus 4 is 7. 8 minus 8 is 0. So my answer is 7 and 7/12. If I'm not sure, I can just multiply 7 times 12 is 84 plus 7 more gives me that 91/12. I can solve multiplication problems or solve problems with multiplication of fractions. Mrs. Wooten has a half a package of Oreos. Mr. Dudley has only 3/8 of what Mrs. Wooty has. What fraction does he have? Well, let's just think about that. 1/2 times 3/8. The word of often means multiplication, so I can't do any cross reducing here, but 1 times 3 is 3. 2 times 8 is 16. I have 3/16 of a pack of Oreos. I can divide fractions without a calculator. Well, division, you have to use the old rule, keep it, change it, and flip it. So keep, change, flip is rule. So we keep this guy, 3/8. We change the sign to multiplication, and we flip this other guy, 5/3. And then we can multiply straight across. Well, I see that I can reduce these. I can divide by 3 on both sides. So now I have 1 times 5 is 5, and I have 8 times 1, which is 8. One more time. You keep it 3/8. You change the sign to multiplication. You flip this one to 5/3. Divide, multiply across. You get 5/8 is your answer there. All right, let's keep rolling. I can divide mixed numbers efficiently without a calculator. 3 times 5 is 15 plus 1. This is going to be 16/5 again. We have to make these into improper fractions. And then we're going to divide that by 1 times 4 is 4 plus 1 is 5/4. Well, we've got to do a keep, change, flip here because we're dividing. So I'm going to keep the first one, 16/5. I'm going to change the sign. I'm going to flip this guy to 4/5. I can't do any cross multiplying or cross division there, but I can just multiply straight across. 16 times 4 is 64. Sorry about that. I'm down here doing this one. 5 times 5 is 25. So we have 64/25, which really means 64 divided by 25. So if I take 64 and I divide it by 25, it's going to go in there 2 times, which is 50. And then when I subtract out, I'm going to have 14 left over. So my answer is 2 and 14/25. And that's in simplest form. 14 and 25 don't share any. Okay? You don't believe me? Well, you can always check your answer on a calculator too if you're able to have that of, you can flip these guys into 3.2, make that into a decimal, and you can divide that by 1.25. 2.56. What? You're not sure if that's the same answer? Well, again, remember, 14 divided by 25 gave you that 0.56. So that's the decimal I came up with. All right. There you go, in case you can't see that. All right. Write the following decimals as a fraction. Well, here's 0.36. The way I do this is I take and put my pen on the decimal. I make a bar. I put a 0 under each digit and put a 1 in front of the whole mess. So I have 36/100ths. So I'm going to divide this each by 4 to start with. So 36 divided by 4 is 9. 100 divided by 4 is 25. Now I have that in simplest form, 9/25. There's nothing that 9 and 25 have in common other than 1. I can write decimals as percentages. So I have 0.65. Well, we already talked about this earlier. You just multiply it by 100. So now you have 65%. Okay? Because remember, 0.65 is really, as a fraction, 65/100ths. So here we go, 65%. Make that look a little more like a 5. All right, solve each problem. You have to multiply decimals. I think the key here when multiplying decimals is just to write it out like a regular problem and ignore the decimals. 3 times 5 is 15. 3 times 3 is 9 and 1 is 10. 0 and put the 10 on. 3 times 1 is 3 plus 1 is 4. I have to 0 down. 1 times 5 is 5. 1 times 3 is 3. 1 times 1 is 1. Add those guys up. 5, 5, 7, 1. Now I count my decimal spots. I take 1 out on the top. I take a second out on top, so I have to put those right back in. I go to the end. 1, 2. My answer is 17.55. Let's just see if that makes sense. About 13 times 1. Well, 13 times 1 would be 13. I had 17.55, so really it's about 13 times 1.5. So yeah, my answer makes sense. It's reasonable. All right. I can divide each problem. I can divide decimals to solve these problems. So first of all, you just have to take and set this up as a division problem. So this is really 4.32, and we're dividing it by 2.4. Well, we can't have decimals in this divisor here, so we have to multiply that by 10 and move it. Literally just move the decimal, but we have to multiply this side by 10 too and move the decimal. So really, my new problem is 24 going into 432. So let's think about that. Does 24 go into 4? No, it does not. Does it go into 43? It goes in there 1 time, so let's put down the 24. I'll trade here. So 13 minus 4 is 9. Now this is a 3. 3 minus 2 is 1. So I have 19 left over. Well, I can still bring down this 2. Does 24 go into 192? Well, I think it does. Because 25 goes into 208 times. So let me just try 8 times 24 off on the side here. 8 times 4 is 32. Put down a 2, carry a 3. 8 times 2 is 16, and 3 makes 192. I hit it right on the nose. So it goes in there 8 times. 8 times 24 is 192. 0 remainder. So the answer to this problem is 18. All right. I can write percentages as fractions. Okay, so we have 42. So I just take 42% and I make it into a decimal, which is 42, right? You just move it 2 places, decimal, and then I make that into a fraction bar. I put a 0 under each digit, put a 1 in front of the whole mess, and I got 42 100ths. Now that guy isn't in simplest form, so what can I do here? Well, I certainly can divide them both by 2. So 42 divided by 2 is 21, and 100 divided by 2 is 50. So I think that's in simplest form. Let's think about 21. 21's factors are 1, 3, 7, and 21. Yeah, and none of those numbers will fit into 50, so this guy is in simplest form. 21/50ths. I can write the following percentages as decimals. Now we have 0.2. Well, at 2%, again, let's think about 25%. I had 25% to make that into a decimal. I'd move the decimal 2 places to get to 0.25. So I'm going to do the same thing with 2%. But a lot of kids think that's just 0.2, but you have to remember to put that placeholder in. That's 0.02 is your decimal there. Okay? Don't forget that. All right, let's keep rolling here. I can write percentages with fractions as a decimal. I like to think about this in terms of the heart when I do this. So I really have 7% and I have 3/8%, right? Well, make 7% into a decimal. Well, I'm going to move it 2 times. I'm going to have 0.07. And then if I take 3 divided by 8 on my calculator, I'm going to get 0.375. So now I can just take and put at the bottom of the heart, I can put these 2 guys together. It's 0.7375. I'm going to write that over here, 0.07375. Now let's think about that. Do you see the 7%? Do you also see the 3/8%? There, I knew you could. All right, so now we have to find 15% of 60. Well, you certainly can box these up, and I'm going to talk about that in a little bit longer, but you can also just think about 15% as a decimal. 15% as a decimal is just 0.15. The word of means multiply, so 0.15 times 60. We don't have 100% of 60. 100% of 60 would be 60. We only have 15%, so 0.15 times 60 gives us 9. And that makes total sense because it's not 100%. It's not even 1/4%. It's 15%. So now we have to find 135% of 60. Well, I can do the same thing. I can move that decimal twice, and now I have 100, which would represent 60%, a whole 60 of 60, plus an additional 35%. So we'll take that. We're looking for something bigger than 60, right? So go ahead and put that in. 1.35 times 60, that equals 81. And it fits what we're looking for too. Sweet! I love it when a plan comes together. All right, now we have 60 and 3/8%. Well, again, you can think about that heart that I did up earlier. You have 60% and you have 3/8%. Just kind of break it down. 60% would be 0.60. 3/8, we already know that's 0.375. So just put those both together. You have 0.60375. 60 and 3/8, right? Multiply that times 160. So I'm going to go ahead and do that. I guess I have to have my calculator here for you to see it. I guess you really can't see my calculator. All right. Well, I'm going to have to slide it over here. I think you can finally see what I'm doing. So I have 0.60 375. There's 60 and 3/8%. I'm going to multiply that times 160. I get 96.6. And that makes sense too. If it was 100% of 160, I'd have 160. If it was 50%, I'd have 80, right? A half of it? But I don't. I got 60 and 3/8%. So my answer fits what I was looking for. Something that's bigger than half but less than a whole. All right. A 5.5% of 120. So now you got this a percent with a decimal in it. It's like 5.5%. So again, think about 25%. You'd make that into a decimal by moving it 2 places to the left. You're dividing by 100. So I'm going to do the same thing here. I'm going to take 5.5 and I'm just going to move it 2 places to the left. You end up getting 0.055, and it makes sense because you can see the 5% and then an additional 0.5% or 0.5%. So again, you can just take and pop that in. We're looking, this is going to take that times 120. So go ahead and do that in my calculator. Clear that baby out. 0.055 times 120. That equals 6.6. Makes sense, right? 10% of this would be 12. So about 5%, yeah, it's going to be just a little bit bigger than 6. All right. All right, we are rolling. Thanks for being patient. I know it's a long video. All right, now I can determine, oops, get it all the way down here. I can find a number equivalent to a given percentage of a number. Well, here's where I really like this whole box idea here. So what number is 15% of 120? Of signifies the whole. And so what we're really looking for with the box is we're looking for a number that's 15% of 100. And we're looking for something that's an equivalent fraction of that number out of 120. So when we use the box, you take and you multiply diagonally and then you divide the other way. So I'm just going to go ahead and do that. And really what we're doing is a one-step equation here in a shortened form. 120 times 15. I'm going to divide that by 100. I get 18. Let's just see if it makes sense. 15% of 100 is equivalent to 18 out of 120. Sweet. Makes sense. All right. What? Let's see here now. 40% of what number? So 40% out of 100%. So we just have to figure out where to put these other ones. 40% of what number? We don't know what number that is. So that's the whole. Is 160. So 40% of some number is 160. So let's go ahead and pop that in. We're going to multiply diagonally and then divide the other way. We have 160. We're going to multiply that times 100. And then we're going to divide that bad boy by 40. We get 400. And let's see if it makes sense. 40% of 100 is like 160 out of 400. Yeah, that looks right. Nice work. I knew you could. There, I knew you could do it. All right. I can estimate the percent of a number with percentages less than 100. All right, so this is a little more complicated. We're not going to be able to use our calculator here. So we have 62% of 80. So the first thing I do is I just kind of round it off and say, let's find 60% of 80. Well, 50% of 80 is going to equal 40. It's half of it. 10% of 80, well, if I think about 80, 10% of it, I can just move the decimal one, which is 8. So if I take and add those two guys together, 40 plus 8, I have 60%. 60% is equal to 48. I'm going to make a little table over here so you can understand that better. We're looking for 60% of 80. Well, we know that 50% is 40. We know that 10% is 8. Here's my 60% when I add those guys together. And 40 plus 8 is 48. I know, it's a gift. What can I say? I can estimate the percent of a number with percentages more than 100. All right, well, let's make this little t again here. So we're looking for 111% of 80. Let's call that baby 110% of 80. All right, so we're really looking for 110% of 80. Well, 100% of anything is the number itself. So 100% of 80 is 80. And then let's think about 10% again. I can just divide by 10 there, and I get 8. So 10% of 80 is going to be 8. So here's my 110%, and I can add these bad boys together, and I get 88. There's my estimate. All right, looking at rational numbers. Is this a rational number? You know what, I think we're going to stop right here. We're going to finish this up here. Classify these as rational numbers. So is this guy rational? Well, a rational number is something that you can write as a fraction. So the square root of 16, well, that means something times something is equal to 16. And the square root of, we could say that 4 times 4 is 16. So the square root of 16 is 4. Can I write 4 as a fraction? I can write it as 4 over 1. So this is rational. Is 1/3 rational? Well, it's written as a fraction, so yes, it is a rational number. 3/8, is it rational? It's written as a fraction. Yes, it is rational. Is pi a rational number? No, because it can't be written as a fraction. We abbreviate it sometimes as 22/7, but pi is 3.1415, sorry, and on and on and on. You know it better than I do. So pi, these would be rational, rational, irrational. So remember, a number is rational if it can be written as a fraction. If it's when you make it into a decimal like this one here, this one repeats itself. This fraction, when you make it into a decimal, it terminates. But pi, it doesn't terminate. So a couple of rules for rational numbers. Most of the numbers you'll deal with as 6th graders will be rational. All right, now we've got to compare a couple things. We have 4 out of 9 here. Let's do that. 4 out of 9. Well, we have to really think of that. That's 4 out of a total of 9, so that's really a fraction like this. So 4 9s is going to be 0.444 repeating, and this is 48%. So when we make that into a decimal, we have 0.48. So whenever you have to compare something in terms of fractions, decimals, and percents, make them into decimals. You can think about money. This is 44 cents, this is 48 cents, this is less. I'll write that over here so you can see 0.44 or 0.4 repeating is less than 0.48. Okay, order the following from least to greatest. All right, let's do these quick here. Again, we'll have to make everything into a decimal. We want to go from least to greatest, so I'm going to just put down 3 lines here. This is my smallest. Here would be my biggest. 5/8, this is 0.625. If you put that into your calculator, I know that one. This is going to be, just move the decimal twice, that's going to be 0.622, and we already have 0.456. So 0.456 is the smallest, 0.456. The largest here is going to be 0.625, 0.625, and then the smallest is 0.622. So they usually want those in their original form. So this one stays the same at 0.456. This one was 62.2%, and this one here was 5/8. Sorry about that. I should have left a little more room to do that. All right, I can solve real-world problems involving decimals, fractions, and percents. The Dudley boys ate 80% of a pizza. Then Tara ate 1/8 of the same pizza. The rest was left for me. What percentage of the pizza did I get left? Well, just remember that there's 100% in a pizza. So I'm going to take 100%. First of all, I got to figure out how much she ate. 1/8. Let's see. Well, 1 divided by 8 is 0.125. But if I move that decimal 2 spots, I'll get 12.5%. So let's see. There was a total of 100. There was a total of 100%. The boys ate 80%. That left 20% left. Tara ate 12.5%. That left me with 7.5% of the pizza left. Okay. All right, they like these problems here. Mr. Zenz drove 750 miles on a 10-day trip. He rented the car for $22 a day, plus 15% per mile after 500 free miles. How much did the rental car cost for the trip? Well, let's see. 750 miles on a 10-day trip, so $22 per day. So he's got the days. He's got 10 days at 22. Well, I can just move the decimal one spot there, multiply that by 10. So he's got $220 for the car. And then he's got 15 cents per mile after 500 free miles. So 750 miles. If you subtract the free ones he's got 250 miles he has to pay for. So he also has 250 miles at 15 cents. So let's get our calculator back for that. Clear that baby out. 250 times 0.15, that's 15 cents, gives me 37.50. Add those guys up. Looks like we got $257.50 for that, for him to rent the car. All right, that's the end of the first part of this review. Thanks for listening. Okay, evaluate using the order of operations. Well, this one's kind of tricky. First of all, we're going to have to do everything on top, then we're going to have to do everything on the bottom, and then we're going to have to divide. That's kind of the rule on one of these ones with the fraction bar. So let's go ahead and do this first thing. We have to go inside the parentheses, so it's going to be 3 plus, and that is not 10, that's 5 squared, so that's 25. Put our parentheses back, we still have 2 squared times 3 on the bottom, so I'll just rewrite this. We'll do this step at a time. So now we have 3 times 28, and we have 2 squared times 3 on the bottom. Just pop that in here real quick. 3 times 28 gives us 84. So now we've got 84 on the top. Now we've got 2 squared times 3 on the bottom. We still have 84 on the top. 2 squared is 4 times 3 on the bottom. The next step, we still have 84. We have 12 on the bottom. And we have 84 divided by 12, which is 7. Step by step. I can't do all those steps in my head. I know many people think they can. I know you think you can, but if you make one simple change each time, you'll get the problem right. All right, use the distributive property to rewrite each expression. We don't need to solve these. So, well, we can just rewrite this. This problem here won't work. We're going to just change this. Let's change this to 4 times 3 minus 4 times 1. Now we can do it. So we can rewrite this as 4 times 3 minus 1. Because the 4 is shared, we can distribute that and put it out front and still take the 3 minus 1, and we'll get the same answer. What, you don't trust me? Well, let's take a look at it. This would be 12 minus 4, correct? That would give us 8. Well, 3 minus 1 is 2. We take that times 4, we'd get 8 too. Yes, it works. This one here, we can just go backwards with the same situation. We can go from one set of parentheses to 2 sets of parentheses. So we can take that 4 times the 3, and we can add that to the 4 times 2. Remember, the plus sign from the middle goes right in between there. So that's rewriting using the distributive property. Okay, which expression can be rewritten using the commutative property as 1 times 2 times 3? Well, remember, the commutative property just means that numbers can move around. They can commute back and forth. So that's with addition and multiplication. So I could just rewrite this one as 1 times 3 times 2. In other words, I can just move the 3, and that's not going to make any difference there. Here's another one. 4 plus 6 plus 5. I can do that, or I can do 6 plus 4 plus 5. You can rearrange and move the numbers around. That's the commutative property. Again, remember the word commute means to move. The associative property, is the way things are grouped. When you have addition and multiplication, a string of numbers that you're multiplying together or adding together, you can group them differently however you want. So in this case, we have 3 times 4. We have to do this first because of the parentheses, but I can rewrite that as 3 times 4 times 5. I can just move the parentheses. Okay. This one here, I can do the same thing with addition. I can write this as 23 plus 6 plus 4, and I can group here first. That would make more sense because this is 10, and 23 plus 10 I could very easily solve as 33. And this one up here, I don't know what 3 times 4 is 12 times 5. I don't know what 12 times 5 is, but I know that 4 times 5 is 20, and I can do 3 times 20 real easily. All right, now these last 2 problems of this review, just simply using those properties to solve expressions. On this one here, I'm just going to take 4 plus 7 first. I'm going to simplify that to 3 times 11. I know that 3 times 11 is 33. I chose not to break this into 3 times 4 and 3 times 7. You don't need to worry about that. You can if you want. This one here, I think I'm going to rewrite this one as 25 times 4 times 10, because I know that 4 25s are 100 times 10 is going to be 1,000. There you go. Thank you very much for listening.